And let's just go through the actual book here. The biggest challenge is did I bring my, Hold on 1 minute. Let me get set up. Oh, I don't need that. Hi. Okay, so usually how we'll demonstrate in class is I'll have the book on one side and I'll have the Xcode on the other. Okay, so I'll put the Xcode over there and the book over here. Or you want the book over there and Xcode there. Probably Xcode over here. More of you are on that side of the room. Okay, so that's why we have two screens. I can have the book on open there and then I could be programming over there. Okay, so you can follow along as well. So hold on, I just have to switch that. Wrong one. Maybe this. There we go. So again, I have this on my iPad. I don't know if I can. There we go. Is that any bigger? Or is it the same? That's about the same. I don't know if you could read that. Then again, I'm going to quit the book over here. And I'm going to start Xcode up. Again, Xcode should be in your dock. It's the one with the big kind of hammer right here. If you look down below there, it looks like a hammer. If you don't have it in your dock, you can get the Xcode by going to Applications, going down to where it says Xcode. It's the last one in the list. If you click on that, you can simply drag it into your dock, and the program will be in your dock. And to start it, you can click on there, and it'll start up. When you start up, you'll notice you've got, the pre-made window there that you see there. Hold on, let me start I'll start when I get back. So when you start Xcode up, this is what you have. I know last class when you were doing the lab, you just double-click their playground and it automatically opened, right? Okay, well here, if you start Xcode by scratch, you'll notice it says getting started with Playground, create a new Xcode project, clone an existing project. In addition, you'll notice it says git rest holding spot, right? If you don't know what GitHub is, we'll talk a little bit about it. One of the things about Xcode is it's built right into Xcode so that you can automatically start developing with other people, sharing code, automatically writing code together. One of the disadvantages, though, is it's not a disadvantage, but you don't have to use Git. So there'll be a checkbox where you can turn it off. I'll show you that in a little bit. Let's just start with the playground for today. For right now, we'll get to making a project in a minute, but let's just follow the book real quick so we can go through some of it. So I'm going to say getting started with Playground, and it should open up. It's going to come up with different types of playgrounds. And the reason why you see different types of playgrounds here is because it's assuming that it needs different resources for different things that you're testing. If you're making a game, you need to have sprites and things like that. You know what a sprite is, but whatever. It's just you need different resources, right? That's why it gives you kind of options as you're going along. So I'm going to say a blank document, just like it says there. I'm going to hit next. It's going to ask me where to save it. You can make yourself a document. I'm going to go into the documents folder here.
and I'm going to make a new folder for all my apps. So as I'm working on my apps in this room, I'm going to keep storing my apps for myself in a folder under Documents. So I'm going to go under New Folder, and I'm going to put my name on it, Jeff's Raskoff's Apps. So again, I'm making a storage spot for all my apps. And I'm going to hit Create. And you can just leave the default playground there if you want My Playground. It doesn't really matter. You hit Create. And again, this looks like it does from the last class. Let's look at the first line there. And the first line inside our playground here is it says import Uikit. Do you see that there? And the reason why it's doing that is that it needs the resources of the Uikit to do certain things, right? The Uikit means user interface, right? UI, user interface. And so whenever you make a default Xcode project or a default playground project, it usually defaults to doing that. Like if we're going to make a map, we're gonna need the UI map stuff. If you're going to be using a programming, like we're going to program a video, and in order to use the video controllers or the music controllers, right? We're going to make a music app that plays music. You need to load in the music stuff as well. So there's different kits. Hence, the UI kit is the user interface kit, which is probably basic for any app that you make. You need a label, you need a button, you need a map, you need an image, and so on. This is a newer version, and you'll notice that you have it looks a little bit different than what they show in the and of course I can't zoom in here. Let me see. I can zoom in on my iPad here. No, it doesn't let me zoom in. But you see, it's a little bit different than the book. Oh, they told you to call it Hello World, and we didn't do that. Oh, and there's where the different options were. Oh, here it is. It talks about in the book about the import Uikit statement. It allows you to use anything from the Uikit framework. Today I'll show you the different parts of the UI frame kit, and I will demonstrate those. Earlier in the Swift REPL, you wrote print hello world to print hello world to the console. Try this playground now. Start a new line and type print hello world. We already have that in there. It's right there. Again, it says hello world right over here. What's going on in the playground, the code, variable, string, hello world. So again, if you look at the code here, the first line says you're making a variable. In addition, it's calling it a string, which is basically text. Usually a string, of course, is going to have quotes around it. Okay, because in the string, it's going to have quotes because it's words on the screen. Because the value to the print function lets you did the hello world. They're asking you to print a string, so they're just telling you to print string, and what they come up. Oh, and then we got to put round brackets, and then it's giving you a separator, terminator, enter placeholders in the source file. I'm trying to read and type at the same time. And we want to put str in there. Let's get rid of this. And is that sort of what they're telling me to do? And then we get hello playground with the /n. Do you remember when I was talking about that? My understanding is a /n is a return. So again, I have print str. This string here is hello world. So this is just a value that holds the word hello world. That's what a variable is. That's what they're trying to show you at the very beginning here. Then they get to the quiz. Whoosh. They love doing these quizzes in the reading here. What is the 3 primary goals of Swift? I thought they were all safe, accurate, fast. How about that? Expressive? I don't know. What do you think? They said 3. Check answer. Oh, accurate. I guess it's not accurate. Okay, let's go to the next one. Which of these features of Swift make it a safe language? What do you think? Type safety? Type inference? That doesn't necessarily make it safety. Optionals? Oh, we got more. All of them, probably. Which one? All of them. All of them. Okay. Which of the following is a great environment for prototyping Swift code? Terminal or playground, right? Playgrounds, yes. What will the following code print to the console? Hello world, hello playground, goodbye playground. Print testing, 1, 2, 3. There is D, yeah. I mean, why? It's not going to do any of the other ones. You're just doing print testing 1, 2, 3. Congratulations, we're smart. Okay, let's move on. 1.2. Okay. Building apps and programming in general is all about working with data. As a developer, you'll need to understand how to handle and store data using clearly defined types. In this lesson, you'll learn how constant and variables enable you to name pieces of data so that you can later in your program you'll define constants and values that don't change and define variables for values that do change. You also learn about types which like blueprints for working with data. Different types can use and storing constants and variables. You will learn these types including in Swift and how Swift handles them. Again, there's a whole bunch of different options in there. You got numbers, strings, and Boolean values are the common ones. And again, you have variables and inferences for writing clean code and so on. So these are the options here. So with constant and variables, we kind of talked about them. Associate a name like age or name with a value of a particular type, like the number 29 or a string John. You can then use the name to reference the values many times in your program. Once it's set, the value of the constant is enumerable, which means it cannot be changed. In contrast, the value of a variable is mutable, which means it can be changed. By defining constant variables, you're asking the compiler to allocate storage for the memory of the device will run the program, and so on. So the first example that they have there in the reading is the let name equal John. So we use the word let to define a constant. The code above creates a new constant called name and assigns the value John to the constant. If you want to access that value in later lines of code, you can use the word name to inference or reference the constant directly. This is quick for reference and especially helpful when you have one value that you use many times. I guess their whole point here at the very beginning is that we want to use words to describe things instead of the actual thing itself. That way we can change the value later. Right? Not a constant, but using words to describe. Like name is much better than using the word John, and so on. Again, they have the word a name assigned the value of John. Again, John is in quotes. And you say print name, the code will print John. So I mean, we could do this inside of Playground itself. And then, on. I missed the John. And then, of course, you could use the word print, and that prints it to the console. And we want to print name, not the word John. and it should then come up with John if we did it right. Hit the play button. There you go. Thank you. Print John. Again, the return at the end. Because name is constant, you can use the value after assigning it. For example, the code won't compile. Oh, what they're trying to say is you can't change the name, right? Because it's a constant. And you'll get an error message. When you want the name and the value to change, it's going to be, of course, a variable. So again, if you look at the reading, it says var age equals 29, print age. So we got var age equals 29, print age, and you got 29. Because age is a variable, you can assign a new value later in the line of code following by the compiler. Again, we could just come over here and type in age equals 30, and then we can say print with the round brackets age again, and we'll get 30 now. Notice how I don't have to tell it what age, we don't have to use the word variable again, right? You just said age, and you gave it a new value. Again, you can assign constant and variables from other constants and variables. This function is useful when you want to copy a value to one or more variables. Again, you'll notice that in the code that they have there, let default score equal 100, variable player 1 equals default score, variable player 2 score equals default score, print player 1 score, print player 2 score, player 1 score equals 200, print player 1 score. You can get the idea is that it'll output 100, 100, or 200. Let's move on. You just learned to use a constant when the value won't change and a variable when the value might change. But there's a nuance here that's worth learning. Even though certain values might be variables, you can represent them with a constant because they won't change during the lifetime of the single execution of the code. Imagine you're calculating information about the distance traveled on a trip. The program can be reused to track many trips over time, but to track one trip at a time. How would you represent the following data in your code? Of course, the starting location is a GPS coordinate of where you start your trip. Once you begin the tracking the trip for your program, the location won't change. That would be a constant, right? Destination, GPS coordinates is where you want to arrive. Your app can be used for many destinations, so you might think of this representative a variable. Once your program begins tracking a trip, the destination won't change. You will represent value with a constant. Okay, so that's, you can change the I guess the destination, right? Current location is something that will always change, right? The GPS coordinates. In fact, when we get to doing the map, we'll actually be using longitude and latitude. Longitude, latitude, that's what I want to say. Right? So when you're making a location on a map, we actually use the coordinates when you're programming a map. Distance traveled, you'll get the value changes as you move. That would be a variable, right? Remaining distance, that of course that'll change too. That'll be a variable. So constants and variable perform very similar jobs. Okay, so you get the idea of that. First, you'll set a value of a constant. The compiler understands it should never be changed. This means you won't be able to build or run your program if you try and change the constant, right? Second, the special optimization that the compiler can make for constant values. When you use a constant value that won't change, the compiler can make a low-level assumption about how to store the value. These adjustments allow the program to execute faster. Third is the idiomatic or correct way to do things in Swift. As you learn more about building software, you'll come to appreciate the best practices for consistently writing clean, reliable code, readable code. That's especially important when working on a team with other developers. You'll also discover the following best practices when making it easier to remember your code does, especially when you want to make changes later on. If you want to be a great developer, you need to follow shared patterns and conventions. This course will guide you towards the best practices for writing Swift. There are rules for naming constants or variables. The compiler enforces the rules, so you won't be able to build or run your program if you break them. The other thing to keep in mind, of course, is that names can't contain mathematical symbols, right? You won't use the caret and the forward slashes, the equal sign, and so on. You can't use that. Names can't contain spaces. Remember that. I think that's a big challenge for a lot of people. You can use the underscore though, but not a space. Names can't begin with a number. And of course, upper and lowercase letters are different. Okay, this is not like CSS. Those of you web developers who used to be able to fudge a little CSS, right? And things like that. This upper and lowercase letters are different. You can't write capital John with a capital J and then lowercase John with a lowercase j. In addition, you'll notice throughout this course they'll use different characters, especially the emoji kind of things, or the dice. You see the dice that they have there? As you're writing your code and you want to use one of those, like you'll notice the dice right there, or let's say you want to use emoji, you could say spell let right, let. And if you notice, to get to those things is underneath the edit symbol. See edit at the very top here in Playground? If you go down, you have emojis and symbols. Do you see them here? It's because you're going to need to know where that's at, because a lot of the assignments, they love emojis, right? Apple loves your little emojis. It thinks, they love those things and symbols. So again, it's here under edit emojis. So you want to enter one of those in. You go down there and you get your emojis. You got emojis. You got the little animal characters. You got your burger characters. You got your sports, so on, so on, so on. You can also go to symbols, as you can see them as well. So I don't know. They were using a dice, weren't they? Here we go. Let's do a dice. So let dice equal 5. Let's see if we can do the print, and then we got to put the dice in there. I don't know. I'm gonna try this. Oh, that didn't work. Expect a pattern. I don't know. I'm doing this wrong. I'm looking at the device, the dice that's there. I thought it was emoji. Maybe I'm doing that wrong. But there is emojis in there, right here. I don't know how they use them. Can I make an emoji there? Oh. Let me try an emoji. What is it? That's a happy guy. Which happy guy is that? Awful. That worked. I don't know. The dice didn't work. The symbol didn't work, but the emoji worked. You see the emoji? Just know where the emojis are at. They're located under edit at the top. You will use those. You can use them in your programming, is what I'm trying to say. They can represent a value, especially when you do certain programs. So, I don't know, the dice didn't work, but the emoji did. And you get the idea there. In addition to the rules, there are some best practices for naming constants and value. Constant and variables should be clear and descriptive, easy to make understand. First name, last name, just like you would in web programming. When you put two or more words together, the convention is to use a camel case, which means you use the lowercase for the first letter and a name capitalized for the second letter. So you can see the example there where default score, the capital S is in there. Default and score. Camel case is easier to read than all other words mushed together. For example, default score is cleaner than default score, and restaurants near current city is clearer than restaurants near. So get used to that and get used to reading that. In addition, remember the uppercase letter. So naming with the initial cap. Right there. See that? Okay. Other than this. That way you can read it easier. Okay. So, and you'll do that throughout the reading as well, and so on. Okay, let's quit for this for now. I know I'm not going to go through all this with you right now. I'll try and speed this up so we can get through this a little bit quicker. because we didn't get to all that. Plus, I read a little bit today. Let's get to Xcode for a moment. I want to demonstrate that. Let me stop this for a moment.